Hey everybody, John from Additive Alliance here with yet another installment about how to build a 3D printer. Today let's talk about linear bearings. There are lots of options out there, and in my opinion there are some that are significantly better than others when you consider things like sound, accuracy, smoothness, and of course cost. So with that, let me flip the camera around. We'll take a look at a few of them I have on hand, which is pretty much the bulk of things, and then we'll go from there. Okay, so here's a smattering of bearings that I happen to have on hand. Let's start with the most simplistic kind you can get, which is basically a pre-oiled bearing like this. So this is simply a brass bearing that has some basically sponges in it that hold a little bit of oil. And they fit onto a rod. They don't have any moving parts within them other than the fact that the bearing itself slides on the rod. They're precision. And they work great for low duty cycle areas of your printer where, say, maybe you want to articulate a tool up or down, or have something that moves relatively infrequently but you need some guidance on it anyway. And this happens to be, I believe, a 6mm diameter version. They come with a little taper here so that they can be pressed into parts that are going to be the housing for the bearing itself. So they come in sizes even bigger. Here's an 8mm version. It's the same, effectively the same thing. You can get them in different lengths as well. They're very inexpensive. And as I mentioned, you can then print a part, press it into the part, and have a mounting system for it. This particular one looks like it mounts to a rail. And they work well as long as it's low duty cycle type stuff. They actually have a rotational component about them as well. As you can see, I can spin that on the shaft just as easily as translate it, which is kind of cool if that's what if you need something that does that. The downside is that if you're going to try and guide something linearly along with this, you may need to have two of these rods, one being fixed, being your reference, and the other one being floating to be able to handle the misalignment, but of course preventing the torque, preventing the bearing from rotating. Then you can step up from there and actually get roller bearings. These are linear roller bearings. They come in different sizes, and again they come so you can actually press them into a housing that you would print. And of course they have rows of bearings. I'm not sure you can see inside of that, but rows of bearings in there. These work great linearly, not well rotationally. This does not want to rotate, but it can a little bit. So it can't be used as something to prevent rotation, but it also should not be used as something that allows it to rotate either. Again, as with the smaller shaft, the smaller bearings, you need two of these shafts, one as a reference and one as a floating anti-rotational shaft to prevent rotation if you're truly going to set up a linear system. I've built some units that actually use these. They're nice and accurate. They're very inexpensive, but they are a bit loud. You hear the machine running and you hear this thing rolling back and forth even when it's lubricated, and even when you buy the sealed style. This style has a seal at the end, which you'd always want to get on a printer because of the dust or the debris that could get onto the bearings. So you always want to get sealed bearings. So they work. They're inexpensive, they're a little loud, they're good for precision. The next style, which is pretty common in the industry, is the contoured rail style. And you can get these from a variety of different places. This particular one is a generic brand I bought off of Amazon. I don't use these in my unit. But I have designed many units in the past that use these high precision. They can come in a variety of loadings, so you can actually get how tightly they're loaded against the profile rail, which dictates how much they can twist or turn, but also limits the amount of freedom they have to roll along the axis you want. These, as you can see, are strictly one-dimensional. They have only 1 degree of freedom. That's along the axis. They don't twist this way, they don't twist this way, they don't twist that way. And of course, they don't translate in either of those other directions either. They're really good for high precision. Their downside is they can be expensive. They can be pricey. And they can be a little bit finicky too. You can buy ones that have sealed ball retainers in there and sealed ends on them. And you can buy ones that don't have that, and as soon as the bearing comes off the rail, as in the case of this one, which is why it has end stops, the balls go everywhere, the bearing's ruined. So there's a whole variety of them. They're not terribly cheap, and they can get a little bit loud if they're not taken care of properly. They are more sensitive to debris than, say, than this style is. I opted not to go with these, but these are a close second to what I actually wound up using in my printer. I went with palm bearings, which are these things. They come in a variety of different styles. This is a 3-banger style. You can see that fits onto the 2020 rail that I've talked about before, the V-groove rail. You can buy them in different sizes, so you can buy them for 2040 or other size rails. This particular one is a 3-bearing style. I actually use the 4-bearing style for my Z-axis. What makes these really neat is the palm material is quiet. So these are super smooth and super quiet, and you can self-adjust their interference. You can barely see it, but these are actually nuts here, and they're cam nuts based into this plate. So they have an eccentric hole. As you turn the nut, it pushes the bearing closer or further away from the actual surface it rides on. So you can self-adjust how tight you want this bearing to ride on the rail. And that is a really cool feature. Even if as they wear, which I've never, after several years of using this, I've never experienced it, but in theory, you can adjust them down and make them even tighter. Really nice bearings, inexpensive, ubiquitous. You can buy all types all over the Amazon and on the internet. And they come in even fancier styles, as mentioned. Here's a couple of them that work on the 40mm rails. You can buy them with 6 bearings in total, or 4 bearings in total. These are what I actually use on my X and Y rails, this style right here with the 4. And you can get them with a variety of different plates on them. I use the wider style on X and Y for more stability, because it spreads out the bearing more, spreads this distance more, is more resistance, offers more resistance to torque in those two directions. But they're super smooth, they're super quiet, very easy to work with. Components are easy to change. I really enjoy these bearings. And if you're questioning whether they're useful in a professional grade unit, the bearings have a continuous operation temperature of up to 130 C. So they work fine in a unit that says that, like mine, that has a environmental temperature of 80 C. There you have it. Okay, so that was my quick take on bearings. If you have any questions or comments, just leave them below. I'd love to hear from you. Cheers.